Good morning, student. Now let's yesterday we complete till here. We learned that what is the electrolytic reduction. The electrolytic reduction, we learned that in electrolyte we with the alumina we have to add cryolite and fluorspar, and why the cryolite we have to add, to cryolite can able to lowest the melting point like 2050 degree centigrade to 950 degree centigrade, and it is also a good electrolyte. And the fluorspar also increase the conductivity, because the mobility of the ions, calcium and ion mobility, which means that moving from one place to another place, that is a mobility. So the mobility of this ion are more, so that's why they can increase the conductivity of the current, so the conductivity in electrolyte. So that is why we are adding the fluorspar, and also it is a good solvent. They can able to dissolve, and they can able to dissolve very well alumina and cryolite both. That's why we are adding a fluorspar. Okay, now let's learn a process. This process, let's learn the process. The next process, in this process what we'll do, that Al2O3 convert into the aluminum, okay, by the electrolytic reaction. Now in electrolytic reaction, first we know that we require electrolyte, which means, what is the electrolyte? The solution. Electrolyte. Now what is the electrolyte? That is a solution which is filled in a electrolytic cell. So the electrolyte, which is electrolyte Al2O3, molten state of Al2O3, then cryolite, which is Na3Al F6, that is a cryolite, plus fluorspar. These three are added in it. The ratio of these three is 1:3:1, which means if we are adding one part of the Al2O3 alumina, then the 3 part of the cryolite and 1 part of the fluorspar that we are adding, that is the ratio. Okay, this much of ratio we are taking, and the mixture of this is known as a cryolite, electrolyte, that we are adding in a shell. Okay, now let's learn the structure, how it's arranged. Okay, so first what we'll do, we'll take a big iron tank. This is a big iron tank we are taking. In this iron tank there is here the outlet, one outlet is there. Okay, now this iron tank is little slanting like this here. Now in this tank, here the inside the layer are made with the graphite, or we can say that carbon form, or graphite. This is the inner side, and that inner side behave as a, this is a inner side and behave as a cathode. Okay, that inner side, this is behave as a cathode. Okay, remember this thing first. Okay, now we feel electrolyte in it. This electrolyte, which is this mixture of this, that electrolyte we fill in it. Okay, now the surface, on the surface of this electrolyte there is a coke powder, a very big coke powder we are adding in it. Here, this is the coke powder. Okay, this is the coke powder we are adding in it. Now why the coke powder we are adding in it? This is a coke powder, I am writing here. So coke powder. Now why coke powder we have to add on the surface of the electrolyte? Because it prevents the heat loss, which means that when we heat this, here from the below we are heating this tank, when we heat this, the energy which is produced in this can prevent the heat. Coke powder, I am writing here, this is a prevent the heat loss. Okay, remember student, we are adding coke powder, which is a prevent the heat loss. Got it? Another purpose also is there, that I will tell you later. Okay, first you need to remember the heat loss, which means that when we are applying that high amount of heat, that that heat loss is not there. So that's why we are adding this coke powder on the surface of the electrolyte. Okay, now another here cathode is there. So the anode we are taking a carbon rods. Here this is carbon rod. In your textbook it is given the big carbon rods are dipping in it. These are the carbon rods dipping into the electrolyte. Okay, so these are the carbon rod, and this carbon rod is behave as a anode. This carbon rod behave as a anode. Okay, now this is the structure of this electrolyte. Structure of the electrolyte. In electrolyte, anode and cathode have to be there. Okay, now remember student, few things that you need to remember always. It is useful for your electrolytic chemistry. In that chapter also it will be useful. So remember and understand very well what I am telling you, that on anode have a always positive charge. Anode have a positive charge and cathode have a negative charge. Remember. Okay, if you can't able to understand, if you can't able to remember, then you can write anode and positive, so Pa. Another thing, on anode always oxidation reaction happen. On anode always oxidation reaction happen. On anode always oxidation, you know what is the oxidation reaction. Okay, so we can write positive anode oxidation, POW. If we write in Hindi, POW. Okay, I am not writing in Gujarati or Hindi, POW it is. So positive charge on anode and oxidation reaction is happening. That is a shortcut. On cathode it is a reduction reaction. So then and negative charge. So negative charge, cathode and reduction. Negative charge, cathode, reduction reaction happen. Okay. Now what is the oxidation reaction and what is the reduction reaction, that you have to remember. Okay. So what we have learned here, the PaO and NCr, oxidation and reduction. Oxidation and reduction. Now oxidation and reduction, which means that in aspect of this scenario, what we can say that on anode the oxidation, which means that the particular metal is lose their electron and convert into the ion, positive charge. Okay, what is the oxidation is? Oxidation is a loss of electron, we can say. Okay, so what happened, the carbon, if the carbon is there, or suppose I'll write Na. So if Na is there, so Na loss electron and it convert into the Na plus. So that is called, this reaction is a oxidation reaction. This reaction is a oxidation reaction. Okay, so we can say that OIL, oiled. Okay, so POW, oxidation is a loss of electron. So in POW oil we are adding, in POW oil we are adding, which means that oxidation is a loss of electron. Got it? And the reduction is what is the reduction? So reduction is gain of electron. Gain of electron. So RIG, rig, we can say RIG. So this thing you need to remember. Oxidation is the loss of electron. Reduction is gaining of electron. Okay, gaining of electron, which means suppose a copper plus 2, when 2 electron it gain, it convert into the copper metal. Copper ion, when it gain 2 electron, it convert into the copper metal. So that is a reduction reaction. So on cathode reduction reaction happen and on anode oxidation reaction happen. Now this, have you understand this? That is very useful and you will learn in electrochemistry this point. Okay, this point you learn very well. So I am not going through in very too much detail, but now let's start this electrolysis process. After applying energy, or here in your textbook it is given that DC current if we apply here, DC current if we apply here, and 100 angstrom current if we apply and 6 volt of battery we put here, then the reaction is moving. Okay, now the reaction going to start. Then what is electrolyte we added in it? We added in it electrolyte is Al2O3, then Na3Al(F6) and CaF2. These three substances we add. So they convert into the ions, which means that is Al3 plus O2 minus, O minus 2. Then here the Na plus Al3 plus F minus, and here Ca2 plus F minus. Okay, so here this the ion will be generated here. In this electrolyte, this many number of ion are liberated in this. Now as I told you, the on anode is a positive charge, so negative charge ion attract towards the anode. Okay, so which negative charge? Oxygen and the fluorine. There are two negative charge. So what reaction happen on anode? What happened? The O2 oxygen is attract towards the anode, and ion F also. And on cathode there are Al plus 3, Na plus and Cu2 plus. This attract towards the cathode, because cathode is a negative charge. So on negative charge, positive charge ion attract, and on anode negative charge, positive charge, so negative charge ion attract towards the anode. Okay, now this two now this many ions are not liberated on cathode. So if we see the electrochemical series or reactivity metal series, so which will come first? Aluminium. So that is why on cathode the aluminium will liberated. This two will not liberated, because the reactivity of aluminium is more, as we learn. Okay, same thing here also. Oxygen is liberated on anode. This is a non-metal, but about this you will learn in a electrochemistry. In that chapter you will learn that which will liberated on anode and cathode, that series also will come. But right now I am telling you here, out of this metal, this aluminium will liberated on cathode because the reactivity of aluminium is more. And here out of this oxygen and fluorine, oxygen can able to liberated on anode, not fluorine. Okay, so this will come here. So according to this scenario, now we'll get that oxygen is coming on anode and aluminium is coming on cathode. So what reaction happen on anode? Oxygen, here the anode, oxygen, anode, which means oxidation, which means gaining of electron. So O minus 2 is here 2. So 2 electron it will gain and convert into the oxygen, and this is like this. This is called nascent oxygen. If it is bracket in nascent, which means newly born oxygen. Nascent oxygen, which is written in bracket, which is called newly born oxygen, and it is very reactive. So immediately these two nascent oxygen combine together and form O2. Okay, so on anode, what is anode? This carbon is an anode. So on carbon atom, on carbon electrode, this electrode, oxygen gas is liberated like this by gaining of electron. Okay, because the anode have a positive charge, so anode have a number of electron, so it gain electron from anode and liberated on anode. Now the cathode, if we talk about cathode, then the what reaction happened? Cathode is a, sorry, here not gaining, oxygen is loss of electron, my mistake student, here at a loss of, my mistake, sorry, my mistake, loss of 2 electron. So that's why here the 2 electron are more, so loss of electron is converting to the oxygen, my mistake. Okay, now here the gain of electron, aluminum. So Al3 plus, when gain to 3 electron, it convert into the Al in molten state. Okay, I am clarified student, here it is my mistake, it will as I told you, the loss of electron, so it will come here. I hope you understand this. Okay, now the what happened on this reaction, now we learn that aluminum is liberated on the cathode and the oxygen is liberated on anode. These are the anode, here the oxygen is liberated. Got it? So what happened, the when the carbon, here the carbon coke are there, so this oxygen and this is the carbon, so this oxygen is react with this carbon and convert into the carbon dioxide, CO2. This oxygen react with the carbon which is on anode, which convert into the carbon dioxide. Same thing happened with this. Okay, so what happened, after some time, this the anode rod which are made from the carbon is slowly and gradually decreasing. The rod mass is decreasing slowly and gradually. Why? Because this oxygen is continuously forming and the oxygen is react with the carbon and convert into the carbon dioxide, which is evaporate. Okay, so we time to time we need to replace this anode, this carbon. Another thing, as I told you, the powder of coke powder also plays here. So instead of, sometime what happened, instead of the liberated oxygen here, when at that time that carbon coke also here present, so it react with this carbon coke and convert into the carbon dioxide. So we can prevent the somehow this rod, we can prevent the somehow little bit amount of the carbon rod, we can make it safe if we add more coke powder in it. So the whatever the oxygen powder liberated on the oxygen gas liberated on this, which react with this coke powder, and that is also convert into the CO2. Okay, so this is the reaction happens. So that is why here the time to time we have to replace this. So this question asked in exam, that the why the time to time carbon rod have to be replaced. So you have an answer now, that during the electrolysis process oxygen is liberated on anode and that anode is made up from carbon. So this oxygen is react with the carbon and convert into the CO2. You can express the reaction also, that O's carbon react with the oxygen, convert into the carbon dioxide. Okay, so these 3 reaction you can explain in a reason also. So that is the reaction. And what happened, this aluminum is liberated on cathode. So it liberated on cathode, so and it is very heavy metal, so that is why it is stored here. So the molten state of the aluminum is coming here, and here is through this outlet it will coming out. So here you will get a 99% of pure aluminum, you will get, not 100%, 99% of aluminum you will get after some time. Okay, so here your complete the Hell-Héroult process is I have explained. If you find any difficulty, if you find any query, then ask me after this video. Okay, do you understand this? You need to remember, student. Okay, so what we have learned, 1:3:1 ratio of this. Then this is the structure, the structure of the cell, iron tank. Here the inside the layer of the graphite or the gas carbon, which is behave as a cathode. Cathode have a negatively charged, reduction reaction happen. This anode is a carbon rod in a parallel series have to be arranged, because the higher amount of the carbon is liberated, that's why it's require more carbon. So that's why here the more number of carbon rod are attached this. Okay, now this dip into the electrolyte, then if we apply the 6 volt of battery and the battery, and then the reaction is happening, and at that time the oxygen is liberated and here the carbon dioxide is evaporated. So that's why we time to time we have to replace this carbon rod, and the aluminum is very heavy metal, so immediately it will come out here after the liberated on cathode, and we can take out that aluminum. Okay, have you understand this, how the ions are this coming? Okay, I hope you understand the full procedure, and this shortcut if you like then you can remember this. Okay, POW or NCR, that is very easy one. NCR, POW, which means positive anode oxidation, negative cathode reduction. It will help you to understand the electrochemistry also very well. You need to remember this thing, it will help you definitely, student. Okay, thank you. If you find any query, then ask me after this video.